So for the people on YouTube, this is the second, technically uh, the third video for this portion of it. The last video that we did, 5.2, we laid out the receptacles, we laid out the lights, we laid out the panels, transformer stuff. Afterwards, in editing, I realized that we had forgotten a couple, or I had forgotten a couple things, such as the water heater, washer dryer, stove. Those are going to be big ticket items. So I wanted to go through and show you how to go about this specifically in an out of the box model. So what I did was I Googled, like I said, stove, water heater, and just brought them in as is. I haven't touched them. So I wanted to show you a couple of different things to do and how to understand what you're looking at as you're bringing these families in. So let's go ahead and start with the stove. All right. So most of this stuff is probably going to be under mechanical equipment. However, as you can see right there, it is technically specialty equipment. So, and I want this to be under mechanical, just so if I need to put 5 or 10 of these in there, I know exactly where these things are. Right now, the only thing is water heater. So how you do that is you will single click, edit family, and then right here, you can change this very simply. Right there. And I don't change any of this information here just because I don't want to mess with it in the mechanical equipment. Electrical equipment is a whole different thing though. So load and close, I don't want to save it, override. Now you can see it's under mechanical equipment. And I'll make sure the rest of it is like that. That's specialty, that's electrical, that's first, that's mechanical. All right, so let me edit this, change it to mechanical. Do the same thing here. Any questions so far?
No.
All right, simple enough. Now we've got all of our mechanical equipment actually under mechanical. Just like that. I'll put them there. So that means there are 4 going to be right here. So that's great. All right, so assuming they were already there because the mechanical people magically put them there, we need to power it. We've got to actually do that. Now on full-fledged buildings, like commercial buildings, things like the water heater will need a disconnect most of the time. However, in residential areas, we can just use a receptacle. What I did was I brought in a receptacle, but I haven't actually messed with it. It's an out-of-the-box receptacle for special purposes. No idea what it's going to look like, but I know it's going to be wrong. So what we need is we're going to need a receptacle there for the water heater. Yeah, we'll do one there for the stove top, and we'll do one here for the dryer. There, so it's blatantly obvious. All right. So what I see is that's going to be 120, 180 VA, and that's not what I want. Okay. Actually, you know what? I want to do that something different. Yeah, there we go. So it's 120 volts, 180 VA, which isn't what we're needing. So what we're going to do is we're going to edit type, duplicate. We're just going to say this is a water heater. On this water heater, we want 240 volts. And probably about a 3 watt water heater. Now the question about that is if that's 2-pole or not. I don't know if it automatically goes there, so let's go find out. So edit family, this big green circle you hear me refer to as a steering wheel. This is what we're connecting whenever we circuit it, is this green steering wheel. When it comes to water heaters, any type of heater like a stove, oven, dryer, those are all balanced loads. So we want that to be balanced. And since we're doing 240 on this water heater, we want 2 poles. And then our voltage is set to whatever our switch voltage is, which is fine. Parent load, we'll call that load as well. Okay. And our power factor, which I think we talked about a little bit in previous videos. If you have not gone to watch that and understand what power factor is, please go do that at some point in time too. But that's just, since these are straight heaters and there's no motor, there's no capacitors, no high frequency switching, stuff like that, the power factor will just be 1. So go to that. That's fine. So now, say our water heater load is 3 kW, 240 volt, 2 pole. And that's that. Okay. So there's 2 ways we can go about this. We can either just leave this as is without messing with it, because right now it doesn't have an electrical steering wheel, a green steering wheel associated with this water heater, and just circuit this, which I will. I'm going to go in power, panel, sure why that's not showing this. Can I assign the voltage 240 is out of range for line voltage? Did we set that at 208? We did. That's right, because it was 3-phase. Let's change that to 208. Circuit, select panel. There we go. All right, that's good to remember. All right, so let's go look at the stove. If we want to, right now there is no electrical thing associated with the stove. Now, obviously, we will need to have a receptacle there for it to physically plug in. But I also want to show you a different way to go about this. You can also edit this family, add the electrical connector to it. We'll just throw it right there and circuit this thing directly. Same reason, so it's going to be 2 low class. So I want this low class to be oven or range, I think is technically what the NEC uses. So instead of having to put in range right here, since there is no range, I want to be able to change this using the load classifications that the model has, not just the family. So what I'm going to do is I'm going to say I want this to equal load class. Since that's fine. Okay. And that load class that I put in is now sitting right here. And I'll be able to change that in the model itself in just a second. Voltage, change that to, so we don't have to get back in and out. And apparent power, and power factor is fine. All right, so we're going to load and close. All right, so now you can see that this information right here shows up. Before it didn't, there was nothing that popped up here. Show it to you actually. See, when I control Z, nothing shows up here because there's no circuits connected, and now there is after we load this thing. So now we need to go to find this information. So we'll edit family. So this is a 208. Range is usually around 1800 just because it's simple and easy. And the load class that we want on here is going to be range. So these load classes that you see here are different than the load classes that you saw in the family itself. So I need to create a range for the load class. And what that means, and I'll just call it range again here. And what that means is I can derate demand based on a certain factor. Okay, so these are my demand factors. For these, I'm going to keep it constant, but if you go through the NEC, it will tell you how you can derate. So after, let's just say there's 12 stoves that you have in a building. Well, obviously not all 12 stoves are going to be pulling maximum amps the entire time. So you can derate all of that based on tables you found in NEC, and that's where you would define it right here. So now I've got range. Okay, so now I'm going to circuit this thing. It goes to LP1, 2 poles, so that's good to go. And like I said, don't forget to install the special receptacle here, just so that it's accounted for. Just like that. And we can even say, okay, It's 208, 0, and this should be under range 2. All right, so if I wanted to add these two together to make our I'll show you that now. Actually, let me show you that now. So if you remember, we were able to go to System Browser, and this shows all of our unassigned information here. That's the special purpose receptacle right there. And if you want to make sure all this stuff is not here and under the actual electrical systems, which we went over last video, this is how you do it. So you edit circuit and add to the circuit, to circuit. And finish. So as you can see, wash machine, all it needs is a single receptacle. So that's all I'm going to put right there by itself, circuited by itself with nothing else on there. So that's what we've got there. And then the dryer is going to also need a 240 receptacle. Create another one, or in this case, a 208, I guess, since we're using 208. Heater, dryer, and this one's probably going to run around 1500 DA. And I just happen to know these offhand. If you get a chance to actually look at cut sheets and whatnot for your equipment that you're going to be using, please use that. Otherwise, there are lots of resources out there that give you typical VA, typical watts for like dryers and stuff. Let's go make sure that we've got everything situated now. Dryer. Okay, so I don't care about the dryer. New transfer switch outside. That's the. Okay, let me do that again so that you can see it. So it says you cannot connect panel to panel LP1 because there aren't enough slots. Do I want to enable feed through lugs? Which in this case, no. We went through feed through lugs on a previous project. Not what we're doing here. So I've got to go put more spaces on this panel. It's just simple. Same click on it, and I want, let's call it 30 for now. Now I should be able to circuit this thing there. And now it goes. Wash machine, I don't care about manual transfer switch, those two. All right, so by the same token, how we added the green steering wheel to this thing, we can actually remove them as well. You can tell it's got it because it's got power right there. So let's go ahead and remove that, just because I don't want to sit there and look at it in our system browser. So let's click on it, delete it, load and close. Same with this one. Thinking there may be something else there, but I'm not worried about it at the moment. No. Oh, there it is. It went away now. Okay, so now we've got all of our stuff circuited except for a manual transfer switch, obviously, which is outside. To LP1. Close that out. Let's go look at LP1, see how we're doing. Any questions so far? I know this is getting kind of dry, but I wanted to show you that in case for everybody on Revit on YouTube and for your future reference, because at some point in time you will need to know that if you're ever drafting. I know it's dry material, but you got to have that knowledge right there. Do you have any questions so far?
I don't know if it's related to exactly what you're going through right now, but it popped into my head. So you originally showed only 12 spaces, and then it gave you the error, and you're like, okay, we'll just add some more. At what point in the design are you actually determining like what panel you're selecting and how much space you want it? Do you do all of this first and then after the fact, you're like, okay, well, now that I know what I have and I have everything loaded on here, we're going to go with this specific panel because this is how much space I want. Like, I guess to boil it down to like one specific question, like when are you determining um this the space that you want on a panel, I think is the right question I'm trying to ask.
It is. I understand your question. And so a lot of the time it's good to get all the stuff circuited and then go back and trim your panel down. So for instance, I could have put 42 circuits in here instead of 30. I could have put 60. I could have put 86. Like those are common sized panels.
Mm-hmm.
And then when everything was all said and done, and yes, this is all the equipment I'm putting in here. Great. If I've got 50 spaces, well, I don't need 50 spaces. So I'm going to trim that down to the next most common circuit quantity out there. Technically, good.
Is there value in having is there value in having additional space on your panel as long as obviously the panel can handle the load? Because maybe I'm saying this wrong, but like I know I think out in the field I've seen where it's like we're looking at the panel and it's okay, so there's physically space because there's obviously like there's physical space, meaning there is a space you can put a breaker on. But then sometimes it's like, okay, yes, there's physical space, but our panel's too loaded, so we obviously can't use this space. But like in that case, does it, I don't know exactly how to ask this question, but in the sense of like, when is there that happy medium of I have space where you can actually put more stuff on this panel versus okay, I don't I don't need any space because like there's obviously nothing else can be put on this panel because it's completely loaded up, I guess is the question I'm asking. And it sounds like there are specific breaker quantities you can put on a breaker, like there's certain amounts, so I'm assuming that's part of it. I don't know if you can find an answer in maybe a question I asked and all that.
So I actually heard 2 or 3 different questions in there. So if you want to specify one, we can start there. And if you want to simplify the question, we can start at that one and continue forward.
Okay, so when is there a you said you heard 3 questions.
I did actually.
When it comes to you have everything on the panel and there is actual load space. I don't know if that's the right word to use, but there's load space on like available. And you are at I don't know the exact numbers, but say there's a 15, you can have 15 spaces, or you can have 30 spaces, and we're looking like what we're looking like right now, like where we are almost loaded up to 15 spaces, but we have additional load that can be added if someone wanted to add stuff to the panel, but clearly we will be out of space. Do you go to the next space quantity if you're in that scenario? I don't know if that was one of the questions you originally were thinking I asked, but
it was. Okay, so let me clarify some verbiage so that I can restate your question and make sure I understood it.
Okay.
So the verbiage that 2 main things is when it comes to a panel board, or most things for that fact, but specifically a panel board, you need both physical space and capacity. So physical space is obviously, can you put more breakers on here? And capacity means, can I actually put more load on here, or am I pulling too many amps? So the way I understood your question was, when you are running out of physical space, but you have plenty of capacity, do we just add more spaces in Revit for now. Is that an accurate understanding of your question?
Yes. More concise too.
Okay. So the answer is yes. As you're doing your design in Revit, add as many spaces in the panel schedules as you need, and whenever you're done adding things, that's when you can go back and trim the panel schedules. So, for instance, if I could get an 18 space panel board, and I know for a fact that I am not putting anything else out here, an 18 space panel board would be totally fine. Since I know this client and they like playing around, I will probably stick with a 30 space panel board so that they can put whatever they want to out there, receptacles, feeding a wellhead, whatever, half a dozen other things. I'm definitely not going to put a 42 space panel board out there because they just don't need that many. And while yes, 18, 30, 42, 60, and 86 are the most common, there's still a couple more out there that you can get for, the stair steps of quantity of spaces. So I think I answered 2 questions that I heard in that. Did you have any additionals?
Is there, and even, is it good practice to have a panel have a panel like for a new project, or you're putting this new panel in your new project, and you're at that, like you said, 18 spaces was the lowest quantity of like spaces that you could put in there. Is it ever good practice to have a panel with absolutely no space at all? Even if it's going to be fully, if it's fully loaded up, there's no space, like, is it good practice to have a panel with absolutely no space in it? Is that good practice to do that?
There is a time when you need to do that, and it is good practice. However, 98% of the time, it is good practice to actually have spares and spaces.
Okay.
Address the 2% of the time first. So if you know that you're right at 80 amps, because this is a 100 amp panel board, it's 80% rated. So at 80 amps, if we put right at 80 amps on here and we didn't want any more on there, then yes, I would probably spread out a couple of like the receptacle loads to take up all of the breaker spaces so that they couldn't physically put anything else on here because I already knew they were at 80 amps. That's like 2% of the time. It's very rare. Anything that you are going to come across, it is actually a good idea to leave spaces and spares on there both. The reason for the spares is because if in construction they realize that they need a couple of things here or there that you didn't show or the client requested at the last minute, well, if you have already told them to include those extra spare breakers in their bid package, they're not having to go to Lowe's, Home Depot, and buy out of pocket. They've already included all of that price in there. They don't have to do change orders. They don't have to do anything else. It's already there. However, if you have only the breakers that you need in there and nothing else but spaces, and something does come up that they need to put in there because the client requested it, okay, they're going to push a change order through and they're going to charge the client $3,000 for a $10 breaker because it's a change order. So yes, leave spaces and spares both in most panel schedules most of the time.
Okay. And that 80% rule of like, so for example, in this one, like it's a 100 amp panel and you would only want to load it up to 80%, which would be 80 amps. That 80 amps total is based off of everything's MCA. Like, so for example, if the dryer's MCA was, I don't know, 11 amps, that would go towards that 80 amp total that you want to reach. You're not talking about the MOCP, which would be that you need the breaker to be like, so say if it was 11 amps was the MCA and the MOCP was 15 amps, which I'm just making an assumption because I know it's like normally like 15, 20, whatever, but say it'd be 15 amps. You want to at least make sure that your breaker is is at least 15 amps, but in this case it'd probably be 20 because you probably normally put 20 amp breakers. I don't know if that's correct, but you do a 20 amp breaker, and the amount that's actually accounted for the maximum amount of amps you want to put on this panel would be that 11 amps. Is that correct?
I'm trying to make sure I understand your question, because I heard two different concepts in there from my electrical standpoint brain. So, okay, so let's. I'm going to answer the two concepts, and if I didn't get your question answered, let me know.
Okay.
So when I said 80% rated panel, that means that the breaker that is protecting this panel is good for 100% of the nameplate of the breaker for 3 hours. Anything after 3 hours, it's probably going to trip because it's an 80% rated breaker. Like that's the idea. They're much cheaper. There's times when you use a 100% rated breaker, and I'm pretty sure we've talked about that in previous videos, but there's times to do 100% rated breaker. Something in the middle of nowhere where you're not even close, no, don't spend the extra money. Use an 80% rated breaker and just be done with it. So we don't want a total of any more than 80 amps on this panel board, because there's a high probability that all of these receptacles, the range, the dryer, the water heater, it's probable that they will all be running at the same time. Now, when it comes to the individual breakers here, yes, these are all going to be rated at, these are all going to be 80% rated breakers. I'm not putting a 100 amp breaker on a branch. I'm not putting a 100% rated breaker on a branch circuit. Okay. So when it comes to this water heater, let's go and do that math real quick. Actually, do you have a calculator?
Yes.
What amperage is this water heater pulling?
14.42 amps for the water heater.
Okay, how did you get that answer?
What I did was, okay, so it's a two pole breaker. So there's that 1500 volt amps on each A and B buses or poles. And I added that, and then I divided by 208, and I got 14.42.
Okay, so 3 kVA, 3000 VA divided by 208 gives you 14.42 amps. Is that what you're saying?
Yeah.
Cool. Your answer is correct, 14.42, 14 amps. How would we go about setting this breaker?
So I would say, I feel like it is safe to say, like, if you actually didn't know that MOCP, I would say it's safe to say to put a 20, because since that 14 is so close to 15 that there's a chance it's not 15. So I feel like it's safer to say 20, and you can always fuse it down if you need to, if you don't know, but that's my answer.
It's actually simple math. So you take the 14.42 and multiply it by 125%. That gives you 18 amps. And the next larger breaker, the next size up from there would be 20 amps. And that's the breaker you use.
That's the way you would do it every single time?
Yes.
It's always 125% more than what the actual MCA is?
Yes.
Okay.
Yes. So if you don't have the MOCP from the manufacturer, that's how you do it. And that's per NEC. That's how you go about doing that. Multiply it times 125%, and then you can do the next size up breaker and be done with it. Now, when you get into larger stuff, this minor side note, by the way, like 800, I think it's 800 amp breaker and above, you can't just jump to the next size breaker because that's just too much. But any branch stuff like this, yes, next size up, totally fine. And prove it. Whenever you put in 15, it's going to give me
tells you no.
Yep, it tells me, hey, you need to be aware this is exceeding 80% of the defined rating. So it's telling me, hey, I've got a problem, my breaker's too small. But it doesn't tell me that whenever I've got 20. All right. So by doing easy math and saying, hey, look, we did the math on the water heater. Would you say it's 1500 VA phase A? The range is less. The dryer is less. This is 900 and 750 respective. So what should our breakers be?
It says that the amount the 1.25 would be 10.8, but if I could be wrong, but I don't think that's an appropriate like that's not like a typical number for a breaker size, and plus like you wouldn't have 11, so I would say 15 amp breaker for the range and 15 amp breaker for the dryer. Because I don't know if I'm assuming they maybe don't, well, this is 10.8 for the range. So I would definitely say 15 amp breaker for the range, and the dryer.
All right. So no, we don't put 10 amp breakers in panel boards. That's the easiest way to say that. That's a whole different story. We don't use 10 amp breakers because that's not an AC thing. And most of the time, 20 amp is acceptable when it comes to stuff like this. Because we're not using anything smaller than a number 12 gauge wire, which can handle, because remember, you're protecting the conductor between breaker and load. You got to size the conductor and then size the breaker. And since we're using 12 gauge and nothing smaller, it can handle 20 amps. Hence, we use a 20 amp breaker.
Okay. Mathematically a 15, but size wise, that makes the most sense for this project would be 20.
Yes, that's correct.
Okay.
All right. So for this one, let's go ahead and play this around a little bit. Because I realized that my numbers are a little rusty.
Do you also add all those extra spaces because of looking at what that breaker looks like right now? It looks like the phases are look unbalanced. Because I'm assuming you'd have to move some stuff. Is that correct?
Yes, we are not quite there yet.
But is that why you also typically just add a bunch of additional so that you have space to play with it?
Yes. Yep. Yeah, and we'll be getting there in just a heartbeat. Okay, so based on our updated range and our updated dryer loads, what should we be actually putting in for breakers now?
That's 30. That's like exactly 30 amps. So, which is 100, which is it's 30.04. So I'm assuming we could round down. So a 30 amp breaker for the dryer. Did the 1.25 rule. 2,500, 5,000 divided by 208. And then multiplied by 1.25. I got 30.04.
Yes.
Why is it saying we're breaking the 80% rule?
Show you. So I just dropped 4 VA, right?
Uh-huh. It's going to say it's okay now, isn't it?
It's totally going to say it's okay now. If my quick swag of the math is right. Yep. No problems.
So because I'm assuming we can't do that, will we just have to go up to the next size?
So that's a great question. The short answer is you don't have to go to the next size. Actually, let's just leave it there. We'll keep it simple. You don't have to go to the next size. The NEC says you can. And since we're talking 0.04 of an amp, I'm not worried about it. We could totally use a 30 amp breaker. So yes, we'll just use a 30 amp breaker. Okay. All right, so yes, 30 amp breaker for the dryer. What about for
I
the
would say that
range?
one, I would assume it could probably stay at 20 because, like, at least numbers wise, it looks really close to what the water heater is. But let's do the math. 1664. Then we go divided by 208. Then we multiply by 1.25. We're at 19.33. So I would say stay at 20 amp breaker.
Yes, we can stay at a 20 amp breaker. And for the record, that is a really small oven. Like normally I would expect that to be a 40 amp breaker because apparently my math isn't quite right. But yeah.
So this example, it's a baby oven and doesn't have that much load.
Right. Yeah. Just to make it a little bit more realistic. 0 there.
Let's
Let's
bump it up.
Let's bump it up. 60. Let's do 7K. Just for easy, fun math.
7,000 divided by 208 times 1.25. We're at 42 amps. I don't know what the next size is. Is it a
These are standard breaker sizes.
sweet 45 then?
You're right. It would be 45. And no problems. So yes, these would be the correct breaker sizes for this. So yes, we've got that all done. All right, so the next thing I want to do is balance out this panel schedule. The easiest way to do that is get all of our 3-phase loads at the top, and then the single phase, and then the 2-pole loads, which we don't have any 3-phase, so we'll just stick with what we got here. All right. Next thing I wanted to show you was the concept of why you can't do some things.
I'm not quite. Doing the panel schedules is kind of fun.
Good. All right. So obviously I have done this to an extreme so that you can see why it's a good idea to balance out your panel schedule. Most of the time you're going to have, if I were to do this on any other project, it's going to be way more than 83 amps. But even on this one, we don't meet the requirement because that 83 amps, assuming everything is actually operating at the same time, will do a nuisance trip on the breaker. The 83 amps here is much more than the 49 here because what this is doing is adding up all 3 VAs, dividing by 208, dividing by √3. And that's where that comes from. So that's one thing you've got to pay attention to when you're doing panel schedules is, do I have a single bus overloaded? In this case, right now, yes, we do. It's just not that big a video because we can just rearrange stuff. Any questions on that?
No.
That's pretty for now. All right, so yes, we're less, but we've still got pretty heavy imbalance, which the utility companies aren't much on. So you kind of starting to get a concept of, okay, here's where we got to play some funny math, right?
Yeah.
Or it's not even really funny math. It's actual like, no, this is kind of stuff you got to pay attention to, which is totally fine. One of the cool things Revit came out with a few years ago was the rebalance loads right here.
Cool.
And sometimes it works great. Sometimes not worth 2 cents. When you click it, that's
pretty good.
Pretty good, yeah. And that's not always how it comes out. So always be aware of that. But it's close enough. So ta-da. The idea is don't overload one phase, Just you got to pay attention to that. So. And if you notice, the entire time we were playing, none of these numbers changed because our overall load of the panel hasn't changed any.
Gotcha.
So even though we've got a bunch of single phase loads on here.
Gotcha. I think if you wanted to make it a little bit better, I think you can move space number 5 to space number 15. I don't know why you would do that because it's like a random gap, but like I think it would make them better.
Something like that.
Yeah.
Yeah. You could totally do that. That's there's no harm in that. So do space, spare. Give them a couple extra spares here. A couple extra spares here. And we'll do spaces all here. Space.
I guess, can you explain the totals at the bottom
Yes, absolutely.
instead of me trying to ask a question?
Yeah, you're totally fine. So again, assuming everything is operating at the given VA, we'll just keep it simple like that, right? You would have 47 amps going down bus bar A. You would have 50 amps on bus bar B, 50 amps on bus bar C. That's those numbers right there. When you look at the mains rating, it is not, sorry, the mains rating is 100 amps for this one, 100 amps for this one, and 100 amps for this one. And that's why we say, hey, look, instead of having three 100s out here, we just say, hey, look, each mains rating is the same to itself, which is 100 amps. So that's why we say there is a 100 amp panel board here.
Gotcha.
This
And
number
that
comes good.
and that max that the 80% is like you don't want each phase to get over 80 amps.
Correct.
Okay.
Because of the upstream breaker only able to handle 80 amps or less for more than 3 hours.
Okay.
Did that answer the conundrum in your brain?
Yes.
Okay, cool.
Because in my head I was like, oh, if you add that up, that's 147. What? And then I didn't realize it because it is, as you said, it's each main is, you have to look at it as each main separate, not it as a total amount.
Correct.
Oh,
For the people on YouTube, I wanted to show you this real quick. Yes, you can change, when you add spares, you can change poles. You can change this. What do you want the spare to be? There we go. And you can even define how much spare load you want. And you can even derate that spare load at some point in time. I'd have to go back and figure that out. I don't remember if that was under the hood or not, but I know that you can do that. This comes in handy whenever you're trying to say, hey, look, I know there's more stuff coming. I can define this as architect additional stuff. If I can spell additional stuff. Wow, I still misspelled that. Anyways, I can say what I want, whatever I need here. I know this is something coming the architect told me, or this is going to be a welder that he's eventually going to put on there. Stuff like that. So, the other thing is, if you notice, and put your drafter's hat on for a minute, this is all left-hand justified. This is all center justified. Revit has done this stuff out of the box for a very long time, and I don't understand why they haven't fixed it outside of they just haven't been called on it enough. I think that was an MLO that we were in. So we want this to be left justified, finish, change templates, MLO.
question, is it maybe this is just out of curiosity, is it maybe, I don't know about the receptacle, like the one on the right, but could it, to make it visible that there is space, like would it make any kind of sense to leave the spares center, so it's like clear that it's like, hey, you have space here, instead of having to really look at the like each phase to have an idea of a part, or reading it, like it's easy catch of an eye of like, okay, there's something different, oh, I have space on this panel, just out of curiosity.
So the short answer to that is yes, that is one way to do it. Another way would be to go into the electrical settings, and what we do normally is do prepared space. And that makes it much easier to see, right?
Gotcha.
Yeah, but like at the company where we work at, it's going to say prepared space. Other companies will say, blank out space or covered space or something to that effect. Because you're right, it is very hard to see the difference between spare and space, and so they'll put some random word. in front of space to say, hey, look, this is different than the things above it. This is a good stopping point before we get into HP1, so that next time we can get an HP1 panel schedule and go through, all the expected stuff again. So let's go ahead and stop here, and next week we will pick up at HP1, and from there we will go into the riser diagram, and I'll show you how to set that up. So before we call it quits, do you have any additional questions?
I don't know if it's the demand factor part, but I've heard oh, sorry. That's not what I'm the having diversity in the panel, like how do you determine that? I don't know if that's something that needs a long answer, but like I've heard of there being diversity, and how do you where do you get that you can do that, and does it always apply to every situation?
The short answer to the first part of that is you get that information from the NEC.
Is there free access to the NEC?
Oh,
Because I know
yes.
like there's stuff like upcodes where upcodes, or I can't think of the one I actually use, that you can like access all the building codes.
Yes, NEC.
It's also it's also in upcodes. Okay.
Yeah. I've got a shortcut to this. Anytime I pull up Chrome, I've got several different versions of the NEC at the ready, so that I can go here quickly. All right, so let's go to table 220.44. There it is. Table 220.44 for non-dwelling receptacles, which doesn't really apply to us because we're in a dwelling, but for most of the other projects you would ever do, it says for the first 10 kVA or less, you shall take it at 100%. Anything over 10 kVA, you can take it at 50%. Does that make sense?
I think so.
And what that would look like is in here. Is setting. Okay, those. Factors. That's how much for. So that was receptacle. Oh, hey, look, it's already in there. So that's what it's saying right here. So anything, greater than 10 kVA, you can take it at 50%. And what that would look like, and I'll actually kind of mess with this so that you can see it, is I want this one a stupid thing. Let's just say this one is. Come on, let's make this. Yeah.
Crazy number. It's going to flag the skip panel schedule, I would assume.
Right. So there's our demand factor right there. So right now we've got 12,340. So it takes the first 10 at 100%, and then the 2,340, it takes half of that, giving us this number.
Gotcha.
So while this demand factor percentage looks weird, it's doing the math of take 10K at 100 and then take half of 2,340, which is 1170.
Okay. So in Revit, this is kind of doing it for you, and you should just kind of double check that the numbers are actually correct. But in the case that I know you don't use your good friend AutoCAD, but in that case, do people typically make what is it called? Do people make like their schedules in Excel, and like it populates all this stuff for them, and then they just throw them in CAD, or
yes.
Do people do everything by hand?
So there's two types of ACAD that I've come across. There's what I call a plain vanilla ACAD, which is just ACAD, AutoCAD. And then there was AutoCAD MEP. Here at the company we work at, we use the plain vanilla version, to my knowledge. Like every time I've ever got in it, it's always just plain vanilla. ACAD MEP actually does the panel schedules. You can actually circuit it. It's very similar to Revit in that aspect, and it automatically does the load factors, best I remember. Here at the company where we work at, we do our stuff in an Excel document that automatically calculates all this stuff because it's a smart Excel document, and then we take that Excel document and put it into the drawings themselves. Hopefully that answers your question.
No, yeah, it does. So either you're using you're doing your panel schedules in Revit because the project's in Revit, and it does it for you. But like I said, like you still double check to make sure it's populating stuff right, because there's still always glitches and everything. But then in the case that you're in AutoCAD, there is access to Excel, like where you, or the MEP version, which yeah, I don't think we use the MEP version. At least I've never seen it. There's like, you can use Excel to kind of help you populate all these things without having to physically do all of it by hand. But at the end of the day, you should double check everything, so you would end up be kind of doing it by hand.
Yes, that's an accurate understanding.
Gotcha.
Cool. So we talked about the receptacle, and I was able to show you that. But the other thing I wanted to show you was range. So in 220.54, for household electric clothes dryers, oh man, I grabbed the wrong one. Oh well. Electric clothes dryers, if you get 1 to 4 dryers, you take it at 100. And then the 5th one, you take it 85. The 6th one, you take it 75, so on and so forth. And even though I've got, I do have a dryer. So it would look something like the effect of this. So 4, 5 to 6, and then 6 to whatever. So that would be 85, 75, 65, so on and so forth. That's how you would do this D rate on clothes dryers.
And this is you don't necessarily have to.
Correct. You don't have to, but the client will like you a lot more. The contractor will like you a lot more, because in normal stuff, you would have everything drastically oversized, like the conductors, the panels, so on and so forth. You'd be saving the client money if you actually did the D rates. The best way to go about that is just default to NEC every single time. And if you can't, then that's where your engineering judgment comes into play. If you had to be standing in front of a jury of 12 with a widow in the, you're looking at a widow and you're trying to explain why you did something that got her husband killed, can you justify that idea?
Where is this? Why was it showing everything at 100% then? I know you did it because you went like way up. Was it because we were below?
Yes, we're below the threshold of starting to be able to D-rate.
Gotcha. Okay. Cool. Yeah. I have no additional questions.
Awesome. All right. We'll call that a day. I'll see you next week.